Good morning. Hi. I had to close that door. We have a lot to talk about this morning because stuff keeps coming down the pipe. This COVID keeps mutating. It's getting into our brain. There's a lot of mitochondria in our brain. It's all throughout our body, but this is a mitochondrial disease. So what does that mean? Mitochondria have their own DNA. They're inside our own cells. Liver cells have up to 2,000 mitochondria. They have their own DNA, each one of them. They ingest oxygen and they excrete nuclear level fuel with using a byproduct of a little teeny bit of glucose that has a very complex breakdown that gives it something called pyruvate. Pyruvate, oxygen, mitochondria, nuclear fuel. That's how we blast into outer space, literally. And blast into our future. That's how we have evolved. Because mitochondria produce materials too. They produce the tau, the tangles, the A beta. They are active in the bone marrow to produce fibrins, fibrous things that keep us, put us together. Here we are. Look at us. We couldn't have done this. We would still be a slimy little worm crawling or, slinking around, whatever, in some swamp somewhere. But no, mitochondria have enabled us to evolve. Excellent. So the latest papers are talking about iron. Now, we've talked about mitochondria a lot. We need to breathe. Hypoxia, low oxygen, causes all diseases. Low oxygen will keep the COVID from coming to us. Look at who's not getting it. Athletes, young children, people who are healthy, people who eat well, people who are not sick from hypoxia that causes all these diseases that are not directly toxic from drinking mercury or something like that. Biological disease is a hypoxic-driven thing. Oxygenation drives the thrival of our biological mechanism, the construction of our biological mechanism, the saving of all of the neurons that can possibly be saved in light of the environment we're living in and how we flow in that environment and respond and breathe into that environment. Woo, I was a singer for many years. You breathe. Takes 2 or 3 seconds for the breath. La, 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 A, B, C, D, E, F, G. I'm pressing oxygen into that, the lungs. So not only have I filled it up, I'm sustaining it because it takes 2 or 3 seconds for the oxygen to transfer through many layers. The glucose has many layers of chemical reactions, but the oxygen just diffuses, but it has to diffuse through. It's very dynamic and it binds. Most of us know this. What does it bind with? Bind? Iron. And so what happens to the iron? The iron is in 2 forms, and there's some papers that have just come out on this. I'm glad these scientists catch up with what I'm doing. Takes them a while, but I'm a modeler. I'm a generalist, speak the language of these different fields and see what they have, these awesome, amazing, phenomenal, brilliant, epic scientists have discovered. And from that, I can say, well, I know how scientists think, and they're not going to report something that's not true for the most part, and so I pick from that and can put it together. So mitochondria, they're full of electrons. Well, they're not full of them. In COVID-19, they're full of them. Fat mitochondria. That's all you get is electrons everywhere. And they're splitting apart at the seams. So what is that? So we're having two types of iron with 2 electrons, which is more dynamic and toxic than the iron with 3 electrons, which has an extra shell and it's dynamic, a little more dynamic. So what does that mean? This is bad and this is good, because when it runs into oxygen, it flips off one of these shells and binds with oxygen and brings the oxygen to the mitochondria, where it offloads I think that's right. Yeah, so it loses, it turns into, to bind to oxygen, right? It loses one of its electrons out here. This is my understanding, and I stand to be corrected because I'm not a organic chemist, but I'm working on it, and I'm following all of this. And what they're talking about now is that this iron, which is toxic and reactive, this is less reactive because it's got kind of a loose shell around it. It just wants to lose the shell, and once it loses the shell, it binds to oxygen. They get together, they come down to the mitochondria. It offloads the iron, this iron 2 offloads the oxygen, and it picks up one of these guys. It picks up an electron. And what happens? Picks up an electron, from my understanding, equals the gentler form of iron that goes back to the lungs. Here's lungs up here, and picks up more oxygen. Now, what's happening is we're losing our oxygen. This disease is killing our oxygen. COVID is just destroying our ability to uptake oxygen. And so this, it's offloading, whatever it's offloaded stays in the it's not picking up the electrons because the electrons are building up in the mitochondria. And why? Oh God, God help us all. So this viral RNA has a positive charge. So it needs a negative. It goes to the mitochondria. And these things are negative, from my understanding. And the mitochondria, because they have a DNA, they can produce RNA, viral RNA, with the negative charge. And so the virus can start manufacturing. And what does it make in here? Well, it gets this part of the RNA, and mitochondria make stuff for us. They produce stuff, tangles and fibers and A beta. They produce A beta under hypoxia. You know, when there's stress, they're like, oh God, we have to fix something. And oh my gosh, we've run out of oxygen, so let's start cleaving everything out of the water. So manganese is found in trees. You know how trees kind of fibrous. That's manganese. And I believe that's manganese split out of water. I did some experiments in Baltimore on that. And it appears that's exactly what it is. And you throw glucose on that, and it gets all gooey. The fibers get gooey. So iron. Now, what happens when this iron is all over the place? To multiply that by 1,000, whatever, million, whatever, it's all over the place. We'll get to that in a minute because they're finding like huge, a thing called ferritin that holds, I think, about 5,000 units of iron, Fe2, which is unused iron. In this form, in this, toxic form, the mitochondria say, oh, poo, I'm in trouble. Let's make some ferritin. Okay, to go get this iron. All right, I'm getting a little messy here, but hey, guess what? Got two sides to this thing. By the time I use it. So that ferritin in healthy people is usually from 0 to 400 units of ferritin. And what they're finding in COVID people, 10 to 20,000 units. Holy moly. Like, I don't even know what the 10 to 20,000 units. So what's going on here? This toxic iron, and I stand to be corrected on the numbers and the electrons and such, but from my understanding, this is what it is. And I've already misspoken on it, but that's okay. The idea, I'm a modeler, I'm a generalist and a modeler. So don't crucify me for missing a detail here and there. Otherwise, I'd be stuck in a silo, churning out, facts and whatever, the specifics of this. So that is the one that has dropped off the oxygen. The oxygen has been dropped off to the mitochondria, at which point a healthy mitochondria will donate in the process of generating nuclear fuel. Part of that process in the mitochondria is the interaction between pyruvate. This is very complex, brilliant work scientists have done. Oxygen and an electron transport chain. So these electrons move along in different stages where different things are created. If there's oxygen, that's success. And an electron, all these electrons that are offloaded are then redonated back. So this toxic iron can become iron that will easily pick up oxygen. That's another thing, has a positive charge. So this will become, when it goes to the lungs, here's the lungs, it loses an electron again and picks up the iron. So, and then it goes back to the mitochondria. So ferritin is all over the place. In other words, iron is not binding to oxygen and not picking up what it does. Actually, good grief. Jeez, I don't know. It doesn't make sense to me. But you know what? A lot of things don't make sense. It's oxymoron. That's the oxymoron of this. And someone may have mixed that up too, because the toxic iron needs oxygen to bind, right? And oxygen is, when it comes together, it loses an electron. And so I guess it picks up that electron, drops it off, picks it up, So there's a lot of this electron exchange, which is also energy, part of the energy bang for our buck here. So bear with me so we've got way too much ferritin. So we're looking at metals. We're looking at hypoxia is the problem. So I continue to talk about that. And the simple fact that, we'll go back to the other side here, because that's not the only thing that happens in the mitochondria, is that the RNA is transcribed for the virus. The virus hits the leader dimer, 5-dimer, or whatever they call it, RNA strand, viral RNA. The leader, that means the big one, the one that is the boss of this virus. Viral RNA at 5, I think it's a dimer. This is the COVID. Goes to the mitochondria. Doesn't go to our DNA, goes to the mitochondria, where it gets the main portion of its replication. It also, the mitochondria create things. They create little bubbles and vesicles, these double membrane vesicles. It is a double membrane vesicle, from my understanding, inner and outer matrix, and it creates these things for us, for our cells. So the double membrane vesicles are created here for the virus. In other words, the weak mitochondria, the susceptible, vulnerable, hypoxic mitochondria, are very much hijacked by this virus, are primarily invaded by this virus. Papers are just starting to come out. I've been saying this since day one. What makes it strong? And they're talking about, and rarely you see, occasionally you see talk about manganese. And they also talk about calcium upregulated. That doesn't mean it's more calcium. That doesn't mean that there's more calcium out here. That means that all the cells are saying, give us calcium. They're saying, bring it to us, bring it to us, bring it to us. No, the calcium's not going anywhere because there's no oxygen. The calcium is also staying in here. What's going out is manganese. And what we can do for these mitochondria is give it manganese, supplemental manganese, so they don't have to shoot it out all day, every day in light of this virus because they're starving for oxygen. Does that make sense? I hope it does. I'm really repeat myself on this, but it's, you know, I don't know. I just feel fortunate I'm in the position to be able to give these lectures and to move this science forward. This COVID-19 is an opportunistic, non-living virus. It has put itself together because this world has deoxygenated over the last couple centuries. And we have evolved oxygen, 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 oxygen. We've evolved. A couple hundred years ago, we stopped providing that oxygen. I don't think it's any coincidence this influenza popped up in, I think it was Quebec. Let's look at that environment. And I'll talk about that later. And now you've got the SARS-1 in 2003, when this global warming was really getting its stead, right? The virus showed up, huh? Mutated, buried. Things got worse. This planet is pretty much hypoxic. We are pretty much hypoxic. Remember how driven we were? Going everywhere. Yeah, how do I survive? How do I survive? That's hypoxia. And so now it has resurrected and moving in on the thing that saved us many years ago. What saved us during the oxygen boom? Mitochondria. When the oxygen levels of the planet went up, this was, whatever, 200 million more plus years ago. Oh, one other thing. Good grief. Where there is causation, all you find is evidence. Neanderthal DNA. DNA has a specific strand that they find in this virus. So back Neanderthals, we were still evolving from a low oxygen planet to an oxygenated planet. So, to me, for them to find a Neanderthal level DNA strand that matches the virus, COVID, has the same strand, I believe this is a sign of de-evolution. Where there's causation, all you find is evidence. We know that low oxygen causes all disease. We know that. 2019 Nobel Prize. Finally, it's been recognized. I've been studying this for years. I studied the solution. Oxygen is the solution. How to practice it, how to trust it, how to engage with it. Proxia, ultroxia, optoxia. I'm, in the process, I'm so, and a lot of this is an oxymoron. In other words, we breathe involuntarily at night. We tank up at night. No, oxygen levels are the lowest at night when our involuntary breath. That's counterintuitive. We think, well, but it's true. That's what we're doing. We're kicking out the carbon dioxide. We're doing all the repair, consolidation. During the day, outside of this plastic box I'm living in, My flowers, sun shines, free energy. Oh, the breeze feels so good. Oh, this is so relaxing. Wow, I'm just ready to, oh, geez, time to drink it. We are building our health. We are evolving in the natural environment. We have cut that off, but we're going to build it back up, aren't we now? Because knowledge is power. So that's the oxymoron. So don't be, and I made up this word, my friend laughed at it, a hypoxymoron. Don't stay hypoxic during the conscious state. So I'm doing lectures on this as well, oxygen and your health. So, all right, so this Neanderthal DNA matches COVID DNA. Oh, wow. Lucky us. Let's just ream that DNA right out of that virus, because we're going to ream it, And what is that going to do? That's going to create that Neanderthal in us. A little bit of it. Because that's what it does. That's what it's doing. It's mutating, using itself to mutate. It's an opportunistic, non-living, non-sentient conglomeration of stuff, of elements, proteins, enzymes, RNA, just little bits and fragments. With so much to learn from these disease models. Let's not lose the opportunity. And it needs our cell to replicate, and it goes right to our mitochondria with the leader part of it, and the mitochondria produce these vesicles. So it's like enslaving our mitochondria, because our mitochondria are vulnerable. We are hypoxic. Go back to my whale conceptual framework that I did at Hopkins, looking at the development of Alzheimer's. Alzheimer's is a hypoxic, pure and simple, hypoxic series of events. There it is. The microcephaly in Northeast Brazil will be I would find that very interesting to see how susceptible those microcephaly children are to this, because in essence, the iron in that environment, we're talking about iron here, right? Toxic iron. I'll put the papers in this area, 2 electrons, and that is toxic. So the iron in the environment in Northeast Brazil is not welcome in first trimester pregnancy. Women are supposed to be anemic. Doctors, let them be anemic, please. You don't have to fix that. Not fixing anything, I don't think. Doesn't make sense. So, because zinc and copper are doing all the work. All right, so, some awesome science in this. I just have to keep going with these papers. I have a couple of minutes. Let me tell you about these papers, please, because I did my homework over the weekend. And we are looking at Singh, Birmingham mitochondria and pathogenesis. SARS hijacks the mitochondria. Woo, COVID-19, distinct, that was the Stanford one. I told you about that. And there's another good one about zinc. All right, let me get back to it. Bear with me. There are a couple of new papers that I actually finished one and started going with the other. Iron dysmetabolism, significant iron dysmetabolism, hyperferritinemia, too much ferritin. That's too much ferritin. Go grabs it, and ferroptosis. I mean, these metals are important. Where are my papers? There are several new papers. I put that in the Cavezzi and Corrao, hemoglobin, iron, and hypoxia beyond inflammation. So how these things, this is a NIH article. Skalny, zinc and respiratory tract infections. Zinc is involved. Mitochondria regulate the zinc. This inflammation is not caused by mitochondria. It's caused by hypoxia. So, I mean, a lot of these papers target mitochondria as the culprit. But, it's like saying a violent child, it's the child. Well, actually, it's the parenting often, or the, poor nutrition, or the lack of sleep, things like that. Look at the etiology. That's something I learned at Hopkins in mental illnesses. So lest we forget, the mitochondria control these states of iron, and they are extremely distressed in light of low oxygen. So they create the double membrane vesicles for the virus. They create the leader RNA. Let's see, we'll put the viral leader RNA. And the nucleolus creates the, so here's our cell, here's the mitochondria. The nucleolus gives it the shorter RNA, which may make it adapt. That's that 3-dimer. This is the 5-dimer, however they call it, 5-dimer. So look at that. The mitochondria are like the working parts and the leading parts of this virus. How do we keep our mitochondria happy? Breathe, baby. Burn, baby, burn. Breathe, 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 baby, burn. Do it. Don't panic. Just do it, and watch my breathing videos. I'm going to do another one right after this. And that keeps the iron employed. The iron workers bring that oxygen with that 3, and they have O2, and then oxygen has lost an electron. When it splits, it gets it back, gets its electron back. This goes down to 2 in the split. I'm not sure what exactly splits it, but I'm sure the mitochondria puts it out. I know the mitochondria puts out manganese to split it from water when we need it. Mitochondria is very helpful that way, isn't it now? That's why manganese, not magnesium, manganese is very helpful to us. Please go out and start taking some manganese. The daily recommended is 3 to 5 milligrams. I've been taking 8 because it sells it, Pure Encapsulation sells it in 8. I've been taking 8 most days of the week. In the beginning, I had to, just do it every other day. Then I did it, took the weekends off, and now I'm doing it. I maybe miss 1 day a week. I'm feeling good. I'm gaining weight a little bit. Why? Because don't have to eat so much. Manganese enables the very. So manganese gets the oxygen for us. The iron brings 2 at a time. The hemoglobin, there's all sorts of stuff going on with hemoglobin too, where the heme, this iron makes the heme. And how many of those are in a single blood cell? One paper said 250,000. So you can get like up to 1 million units of blood, of oxygen in a single red blood cell. That seems a little extreme, but you know what? Look at us. Look at us. You think this is a no-cost organism? No, we need as much. We need all of that fuel. And our environment, our, choices, our, self-actualization, we've been so blessed to be able to move into life as such refined, sophisticated, musical, artistic, verbalized. We need to be very careful to preserve the best parts of that. And to continue to make good choices, not just fear-based ones. So, it's some complicated stuff, but I just keep saying the same thing over and over again. The main thing is that this virus is moving in on our hypoxic state. And how do we breathe? Come to my breathing lesson. Long neck, loose neck. That's the main thing. Because when we do this, when we think, oh my God, this seizes up. And you know what's in this area? The involuntary breathing. Our breathing is in this area. We seize this, we're going to and when we do that, the amygdala locks in as if, we just saw a saber-toothed tiger. And back a few hundred years ago, 1,000 years ago, heck, all sorts of stuff was crawling out all the time. I mean, we got, we probably breathed more back then than we do now, because we just activate it out of habit. Back then it was like, tag on, what a planet we're living on. We know what to do, you know, when something really scares us. All right. On that note, we will end, and, you know, keep coming, keep listening. Blessings.